Well, welcome everybody. We're really excited to have Marcel Studer here today to present about these amazing, huge lift slide doors and the install details there. And Kevin Brennan's going to be sharing some airtightness details from Cornell Tech Tower. It's going to be a great program. So you are at a program that is hosted by Passive House Accelerator, and we're a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. And we publish articles and interviews, and we produce weekly virtual confabs like today's Construction Tech, as well as tomorrow's Global Passive House Happy Hour. And we're really excited this week to be aligning our work with the fine work of Passive House Canada and the Passive House Canada Summit that's going on as we speak. So Construction Tech Tuesdays is co-hosted by Kevin Brennan, Shaun St-Amour, and Wille. And we launched this event or this series to share the technique, and the technology of passive house construction tech. So each week we'll welcome guest practitioners like Marcel to dive into the details of practice with the builder and tradesperson as our target audience. So we welcome folks from all corners of the construction and design world to join us each week. I want to also mention that to encourage everybody to stay for the, what we call it, the overtime at the top of the hour, 1 hour from now, because we have a very cool video from somebody who you may know as the godfather of soul, Mr. Dynamite, or Soul Brother #1. He's also a spokesperson for blower doors and blower door testing. It's real. It's amazing. You don't want to miss it. All right. So with that, I'll hand it off.
Well, welcome to Tech Tuesday, guys. I'm Kevin Brennan, one of your many hosts. I'm going to dive in to what is the funk and where did the funk come from? So the funk, to me, was discovered on site. And when you're on site and you're working on small buildings, you've got a small team of people that you can kick ideas around with. So you would talk to the site supervisor, the guys on your team, and be like, hey, can we make this airtight? What do we really need to do to make it airtight? Let's look at the technical data sheets. Let's look at the website of the manufacturer, see what kind of really cool options they have for airtightness. Do they have a fluid? Do they have gaskets? Do they have tapes? Do they have things that really kind of can help you be able to overcome the challenges of airtightness? And then you go to Instagram, right? And you're on Instagram and you're typing in #PassiveHouse, and you see all this international airtightness pieces of love, and it's like, man, that's awesome. That's how did they do that? I wish I had that tape. I wish I had that sealant. How do I do that? And then you start teaching classes, and you're teaching this class called the Passive House Tradesperson, and this nice gentleman comes all the way from Toronto to New York City to take a class in the Bronx, and that's Jesse Matthews. So he found us on the internet. He was one of our first international students at the Tradesperson Training Center in the Bronx in the class that I taught. And I'm like, this isn't his first rodeo. He knows a little bit about airtightness. So we spent 5 days together. We talked technical details. I'd see him at conferences. We became friends. And then he starts sending me pictures of all the cool stuff he's doing. So after talking through the details, I'm like, man, we should kind of like share some more information. Long story short, a few presentations promoted in the international conference and New York Passive House and throughout there. Myself and Jesse and Marcel have finally come together for a session at the Passive House Summit in Canada. And we're going to be talking about field notes. But really what we're talking about is the funk. And when we say the funk, it's the way that when knowing the rules of the game, what the airtightness goals are, it's like, how do you overcome those really challenging points of view? So I think I'll kick it over to Shaun, and then I'll go through a few site pictures about the funk that we did at 2 projects. One is at Cornell Tech, the high-rise and Roosevelt Island, and the one major challenge there that we did. And then the other one was an even more challenging project on 86th Street on the Upper West Side of Manhattan. But Shaun, do you have anything to add?
Yeah. I do. I just want to say a quick hello to everybody. Welcome to everybody. And we could, because I got a classic beverage here. Cheers, everybody. Cheers to some great Canadian funk. Cheers to all the great stuff. But one of the great things is that we can actually learn some of this funk. And I'm going to put in the chat here of a bunch of tradesperson courses that are being offered next year from BCIT, which again is the technical school in British Columbia. Southern Alberta has Sate and Nate have some courses, and I also know that in February Passos Canada is going to have some tradesperson courses. So wherever you are, you can come across, fly in, take the tradesperson, and learn some funk. Back to you, Kevin.
So this is Cornell Tech. All right, we'll take you through a slideshow. Cornell Tech's located on Roosevelt Island. It was a project that was a part of a big grant proposal for the incubator when Cornell and New York City technology come over, and they so pretty much, long story short, they used Passive House to as the dorm residence to attract and win the grant for a larger complex. But at the same time, they were like, we've never done this before. Do we know how to do it? So a really strong team of architects and consultants and a construction management team and general contractor came together, and they said, we can do it. It's a panelized construction. The next slide is a kind of like animation of how the project went together. It was 2,600 Halfin clips, panelized construction that went through, right? And the project goes up and up. So on the next image, besides that, this is the team, right? So the team is Monadnock Construction. That's Alex down here at the bottom. He was the project executive. Really skillful. And these are all the site superintendents, the project managers, even the administrative assistant in the office. This is at the site training that we did on site nights and weekends with the Monadnock team to understand the basic rules of Passive House. So after they took the training and the class, they were like, hey, would you be willing to come help us out and work on this project with us as like an assistant super? Or I think I gave myself a title of the high performance building specialist, the HPBBS or so. It wasn't really anything, but I went there and I tried to solve problems and make sure that the air tightness and the thermal bridging goals were being met. And at the end of the project, we would pass our goals. So this was the challenge. All right. So the challenge is, between the inside and the outside, they had this fancy condenser room. We had to get HVAC pipes through the envelope and make sure that they were airtight and sealed properly. They had to be airtight from the inside at the interior air barrier, but they also had to be airtight at the exterior air barrier, which was a Grace product. So on my side, the primary air barrier was the membrane. So how did we do that? So this is Lou, this is Matt. They're the people who make the project happen. But at certain times, you have to come together and figure out a solution to a problem. So we all put our heads together, and we said, there's got to be a better way. 475 Proclima sold a product that was a Roflex, or it's a grommet, it's a gasket Coflex. It's a little EPDM rubber that allows the pipe penetrations to be squeezed through. They also have one where you can make your own penetration. So I called Flores. I was like, hey, do you guys make this in a 24 by 18? They were like, no. And then I was like, oh man, that would be great if you did. And they're like, no, we can't do it. And then I bought a few and I played around with it and I tinkered and I talked to the guys on the team and they were like, I think we can order some EPDM roofing membrane from Amazon or the interweb. And I think we might be able to make this on our own and it might save us some time rather than taping. Now, this is a union project. So this needed to be done by the union carpenters that had the air barrier assigned on their project. So we took a team of guys and we trained them. And then we started figuring out who was really talented. So Big Mike was really talented. This was the troubleshooting and the planning that we did. And these are the copper pipes that needed to fit in. They needed to be spaced out this way so that the pipe installation could be completely put around the actual pipe penetrations. This is what the kind of like it came together as being a little funky, meaning that each pipe penetration was slightly smaller than the other. The pipe screwed through. They were stubs. They were 18 to 24 inches long, I think. And then they had to be brazed. So it's very common that the guys who do the HVAC brazing with that hot torch will burn our membrane, or they're used to working on hard surfaces. And so we needed to make sure they had a proper distance to make sure that that wouldn't happen. That's the other side of the penetration. And you can tell that they weren't quite as accurate as they should be with their holes like normal construction. So we had to fix that on the outside. But by doing these on the inside, they were pre-set up, and we're able to execute really, really airtight penetrations without having to do too much repair work. That's what it started to look like. You can see that it's not an easy area to work with the stack drains. These are the drains for the this kind of like balcony system that's there. And that's what it looked like on the inside. The pipes are fully brazed, they're sealed, and then there's a drop soffit on the inside. These will eventually get fully insulated with heavy duty insulation that's completely, done to the max. That's what it looked like on the outside, and the insulation got fully sealed all the way around, tightly fit on each pipe, and then put back, and then a panel went over the outside. So that's the funk from Cornell Tech. And then I'll stop sharing my screen for a minute, and I'll pull up pictures from another project.
So that's the results. Probably most of you Canadians got this, but not everyone.
We didn't do too badly there.
Nice.
So the Caesar, Bloody Mary, what you guys call it, we put in clamato juice, which is clam nectar. That was correct. Poutine doesn't have baked potatoes, it's fries, gravy, and cheese curds. Pretty much the national dish of Canada, definitely Quebec. And yes, it's true. Canada leads per capita with donut shops. And second in place is Japan, which is even more surprising. And the Hawaiian pizza was invented in Canada by a Greek immigrant in Ontario in 1962.
What a contribution.
And a double-double, that's not a double-baked bagel. It's a coffee with 2 creams and 2 sugars. That's what we need to keep us going in the Great White North in the wintertime. And it's true that there is a drink in Dawson City that has a toe in it. And the story goes that one settler came into that pub and he had to cut off his toe because of frostbites, and hence the drink was invented.
But what do they use as a toe today? Put your own toe in there?
Hey, you got to go to Dawson City to find out, my friend. So next COVID, once it's over, drive north.
It's worth a trip.
All right. So just to set this up, this is a multifamily project up in the 86th Street, shooting for Passive House. Don't have a picture of the 2 buildings, so it's kind of difficult to see, but I'll talk you guys through it. If you can imagine, there are 2 buildings, one on 86th Street, which is the main building, and then on 2nd Avenue, there's a sliver building. And in order to maximize the real estate square footage, they built both buildings together, and they're kind of interconnected. But seismically, they need to be separated. We have a gigantic problem here, is that we have 2 separate buildings being built that can't be put together, and we need to put an air barrier on the outside. We need to make sure it's airtight and it passes our blower door, and it needs to be fireproofed and meet the finishes that coming up. So there's some troubles there, and 2-dimensionally, it seems like it might be a little easier. So this is the second picture where you can see bright to outside. This is 9 stories of this on the sliver building, and we're all sitting there scratching our heads and like, how do we figure this out? So what do we do? And we need to funk. We revert back to our technical details. So we were working with an EPIS manufacturer. We went to their technical details, had a meeting with their rep, and we were asking, like, what product do you have that can solve this? They were mentioning M-Seal. I'm like, I don't know how airtight that might be. We might need to work on our your current systems. So then we went to a different manufacturer. We focused from the inside, and then we worked our way out. So you can see the large holes that are penetrating through the building. We stuffed it from the outside with a little bit of rock wool just as a placeholder, right? And then we used the spray foam, right? So the spray foam was there just to seal the gaps, and that if the buildings moved, the spray foam would compress. So it's not an air barrier being used here in any way. It's just acting as a backer for our products, right? So we then have the spray foam, we shave it flush, and we found this great product by 3M that has an intumescent fire coating on it. So it reacts when it hits the heat, and it chars, and it's able to use to get us, I'm not sure of the rating, but the architect did due diligence and made sure that it was meeting the requirements. So with the GC's team, we were able to do the training. He's doing the spray foam. You might be able to see the video. Not really earth shattering, but taking a laborer and teaching them how to use spray foam that needs to be at the proper temperature, the kits, that was kind of difficult. But George and his team, you always find that right person on the site that could just able to like get things done. And George was that person. Cut it flush, make it nice and neat. Now it's coming across. And now we start getting the 3M fire tape down. So to me, this is our primary air barrier of our blower door, meaning like we have to stop the air here at the internal safe face so that we don't have this interstitial leakage that goes out to the outside. So this was kind of like our belt and suspenders approach towards air tightness. We're using our fire stopping to be our primary air barrier here. You can see this very intricate inside corner. We showed them how to do the inside corner. That's George pressing it. That's him practicing making the inside corner. So it all starts to come together that the 3M taping is happening. This 3M tape is very similar to the pressurized acrylic tapes that you have from the other manufacturers there. They were able to get an intumescent coating on it. It does two birds with one stone. All right, so this is George, and he's spraying that upper lip of that project there. And then he's taping it, right? So then the tape goes in that corner, because this is two pieces of concrete that are separated, jogged on top of each other, so that the floors aren't really connected, but they kind of almost like a Jenga, or not Jenga, but a Tetris puzzle we put together. So now we move to the outside. So on the outside, we have it has to be an expansion joint that's put on the inside of here. And how do we take this air barrier and connect this air barrier? So when we sat down with the rep, they said that any product can go on top of this Tremco Exo Air product. So we were able to work this expansion joint for 9 stories and then coat it over with the other manufacturer's air barrier. So this is George. He's taking it and you got to press it in. So any expansion joint greater than 2 inches needs space for it to move in. And if you can't really see it from this picture, but that piece of peel and stick has another piece of peel and stick on top of it that gives it its stretchiness without compromising its integrity if the building ever moves. All right, so there's George putting it on, pressing it, rolling it, and you can see that it's one monolithic piece that goes all the way up, and it's pressed in. So if the building moves, and that's what I would call the funk, right? So you're using other manufacturers to hit your air tightness goals. And then this EIF system is going to come all the way over and cover this expansion joint. I think there was an M-Seal product that went in between the two buildings. So just in case it moves, it didn't compromise the finish. But George is the man in that he's the one who took on the challenge and was able to get this funk with a little bit of help from his friends, which is me and the site supers and the sales reps, to make sure that this building had a fighting chance. I'll pull up the picture later on and I'll let you guys know, but it passed its blower door test results for PHI. So I thank you guys, and that is the funk.
Marcel, you want to take over, and do
Yes.
you want to provide answers to that
I'll do
second
that,
poll?
yeah.
Some Canadian trivia before you give us your funk.
Inventions. Aluminum foil, not Canadian, actually Swiss. I put it in there because I knew that. The walkie-talkie though, the basketball, the plexiglass, and the gas mask are Canadian. We're going to get into that a little bit. And surprisingly, snowshoes were invented like 4,000 to 6,000 years ago in Asia. So I didn't know that, but now here we go. This guy, Donald Hinks, invented the walkie-talkie, and he was actually working in Trail, BC at one Cominco, which is was a big factory. And this was his hobby, fiddling around with radio apparatus. And he basically invented this in 1937. Very Canadian. And basketball, you know, probably more popular now in the US than in Canada, was invented by this guy called James Naismith in 1891. And he basically just asked the janitor for a basket and put it up high on the gallery and then threw a soccer ball into it. And there you go, basketball was invented. Plexiglass, there's a few people who kind of claim that invention, but the Canadian called William Chalmers was very instrumental of creating the material called methyl metacrylate, which is then put into plexiglass. and obviously a very commonly used product these days with COVID. The gas mask, there's a few different renditions of this, but the main guy who was responsible for the first gas mask is seen in the picture here, basically just like a bag with some with a eye slot to look through, and this was in World War I. It was Clooney McPherson, a Newfie, as we call that in Canada, a person from Newfoundland, part of the Canadian Army at the time. Great. I hope you enjoyed that. Thank you very much, Passive House Accelerator, Construction Tech, all you great guys for inviting me here, guys and girls, obviously. So a little bit about the history of how I met Kevin and how I got involved into Passive House. So Kevin actually was my teacher. The first class I took on Passive House, it was Passive House construction course that Kevin taught in Vancouver at BCIT, and both Sandra, Roller, and myself were attending. So it was more like a kind of trainer course as well. And Kevin and me hit it off pretty well. And yeah, we had a few of these while Kevin was in town. And we have been in contact since then. And a little bit about myself. I came to Canada 20 years ago from Switzerland. My background is actually in architecture, but as soon as I came to Canada, I got involved in building. I'm partner of Econ Group with my partner, Mike, who's sitting next to me now. You see him. And we formed Econ Group and got involved in Passive House pretty early on, around 2007. And I'll talk a little bit more about that when I introduce my mentor towards the end of this session. So the funk, as we talked about, is a challenge that we're all facing on our building sites. And the one I'm going to talk about is in this particular project in North Vancouver. It's a single family Passive House residence. You can see some of the pictures, very modern design, southern exposure with a view to the city. So large glass openings to accommodate that. And I want to really talk about the challenge, the dilemma of installing these lift and slides, humongous windows, doors. A little bit background of the word funk, and like so many things that we deal with, it has a Germanic background. So if we go back, the word funk actually means spark, and that's in Old Germanic. So really a positive thing can be something that creates a solution, a spark to fix something. So that's the way we look at it here. And only later on it has a negative meaning as well. So I'll start with a quote from David Bowie, funk, I've never considered myself funky. So we all start out like that. We never really, we see a challenge and a problem and we don't know how to tackle it. And our challenge here was to get these two large lift and slide units into our building. And we have this 6-foot overhang on the roof and also a balcony. So how can we slot those large units into the building and install them? So that's what we're going to go through now. We're going to play that funky music, at least we try as white boys. And of course, the weather is always in our favor in Canada, the big white north, as we call it. While in Vancouver, it's very rare, but it just happened then when our windows got delivered from Austria in this large open top container. Actually made their way through the Panama Canal, got directly into Vancouver Harbor. And of course, it snowed that day, but not much. We're pretty fortunate here with the rest of Canada. So open top container, we could lift those units out. That was important. And they're very large. So they're like 9 by 20 feet. And they're super heavy too. So 1,600 pounds. And they're not that cheap. So around 12,000 euros is what we bought them for. And because they're lift and slide, we can't just attach some suction cups to the side and lift them, because the sliding part of the lift and slide would lift out and can't really structurally support the entire window load. So together with the manufacturer, they dedicated 3 spots where we can attach the crane chains here, and they actually made those steel anchors, steel plates anchors for us and shipped them from Austria with the rest of the windows. And they told us exactly where to screw them. So one in the middle where the mullion is, and then two on either side of it. And they actually added in a stiffener as well there. Sorry, I went the wrong way. Just to not put any pressure on the frame, because on the sliding part at that point, it's just the frame really holding that up. So that's how we started out. We knew that's what we had to deal with, those 3 anchor points. And then it was actually my business partner, Mike, who came up with this idea, how we're going to install them. So how do we get those in under the overhang? We have a crane. We have 2 scenarios. One has a deck and one doesn't. So where we didn't have a deck, we built a scaffolding. And we're bringing in the window now and pull it in with some manpower as close as possible, at least on an angle, still hooked into the crane. And now we need to get it into the envelope. So we used some engine hoists from a place like Princess Auto. They're like, $50 a piece. 3 of those that are corresponding to those 3 anchor points that we have on the window with those brackets. They get hooked in, and we tip now the window, start pulling and lifting the load with those engine hoists. So now we can unhook the crane, and then we can actually pull it up so high that we can lift the bottom of the window in and push it into its place. So we're dancing, we're singing, moving, and we're doing the grooving. And here is some pictures from the actual install. You can see the engine hoists in place, the large lift and slide coming in. And then, the manpower to get it actually in place still with some suction cups, and then lifting it into the position and bang, in place. And the next few slides are going to show you how we tied it into our insulation layer and airtight layer here. I think this is a quote from James Brown, and it starts out as saying he's only got a grade 7 education, but he has a doctorate in funk, and he likes to put it to good use. So a good motto for everyone to, it doesn't really matter what education, what background you have. If you can visualize the problem and come up with a solution like this, you're the doctor of funk. So a little CAD detail of what that slider unit actually looks like. It's very wide. It's 9 inches wide, super beefy wood frame. Obviously, one portion is fixed on the outside here, and the internal one is sliding. And we also got this integral threshold close to 3 inches. That is out of insulating material, and it accommodates the sliding track. So we had to figure out how we're going to support that. And this is now on the section where there's no deck built. How we're going to support that and put it out into our insulation layer. So we basically did that in a combination of a parallam beam and a fiberglass angle, and then slotting in the insulation there. So that's what it looked like on site in that location before the insulation got on. We also used offcuts of that same fiberglass angle to hold it in on the sides and even on the top, because it's such a long unit, 20 feet. We still needed a bit of wind load transfer to the structure. So we added these slotted angles here because we didn't want to have structural settlement load crushing the window. So we just over drills an oblong hole here for the wood screws to be held in. And that's how the funk goes. I hope you enjoyed this. It's not rocket science. Again, in the end, it's we're using a come along or an engine hoist, so very old technology to lift a really heavy door and put it nicely into our passive house.
I would just like to say, amazing job, Marcel. That was the hurdles you came with, totally overcoming all your challenges. Just resorting back to last week, I think Jake Burton should look at this video, and I think we solved this problem that he was talking about on the last Tech Tuesday. Getting the solution you did, I think could help everyone out on those sites. So amazing job, and I don't know if it's funk or just pure class passing house workmanship. I mean, those
bit of both.
those fiberglass angles, they were kind of funky. I mean, who makes those?
There's a place called Fiberman in Vancouver where you just buy 20-foot lengths, and then we just drop them on the job saw. And
engineering wise, they all
yeah,
worked out.
Yeah. We actually tried to use in another project tried to use them as a brick ledger, but that was too much weight. There's a, in this case, we half supported the window on wood on the PSL, and then it was only the second half that was supported by the angle. So, because it wouldn't have been able to hold that whole weight of that large window.
Nice.
I would have to say that the technique of lifting up these windows, right, this large glazing, and moving them to the scaffold area and dropping them in place, when we get to technique, and then as Kevin said, the technology of adding in the fiberglass and the technical aspect of pre-planning that separation, absolutely brilliant, Marcel. You get 1, 2, 3 thumbs up.
Thanks, Mark. Appreciate it. Great. So back to the trivia. So here are the solutions, and I'm just going to talk about the ones that are not true first. The beaver tail, it's this little donut pancake thingy that is a Canadian pastry. So that's not, we're not eating beaver's tails when we're talking about eating beaver tails. And it's not true that every 5th Canadian owns a snowmobile. It's about every 60th person. So we're not that, outdoorsy, rednecky all over Canada. And we don't have that much snow for that matter in all the areas to use them. Anyway, let's look at the correct ones. And it is actually true that it is a crime to read a comic that has criminal content. And if you look at the superhero comics, most of them have. So you could say it's a criminal to read a superhero comic. And this really surprised me as well. There is an area on the Hudson Bay, which is kind of central north coast of Canada. There is lower levels of gravity in that area than the rest of the planet. Don't ask me why. I'm sure some geophysicists could explain this. And yes, this is straight from Canada Post's webpage. You can send, oh no, sorry, that's the wrong one. The word A, we say a lot, Canadian A, is actually in the Oxford Dictionary. And this is straight out from a screenshot from that Oxford Dictionary and the several meanings of it. So a very Canadian word. And yes, it's true, this is from Canada Post, that we can send a letter to Santa because the North Pole, part of the North Pole is Canadian. And if the address is down there, if you want to do so, and you actually get a reply back as well. So please tell your kids. That's it from me. I'll stop sharing here and I'll pass it back to Shaun.
Yeah, Marcel, a couple questions because I forgot. What was the name of the window manufacturer?
It's called SIGG, so SIGG. It's they have a Passiva certified window line. The sliders, the lift and slide, are not certified. That's quite common, that because of the thermal performance of those large mullions, that they can't pass the PHI certification. But they have a model by the Fraunhofer Institute. The U value is modeled, so we use that for the PHPP. And they're based out of Austria, Bregenz area.
So just a point of note, anyone ordering lift and slide windows and doors, make sure you look at the technical details, make sure you ask a lot of questions on air tightness and testing and how it's done in Europe. We have had a few projects that we've made the decision on uncertified passive house project, and they went with a level 1 gasketing system, and that was not the smartest decision because level 1 is not very airtight. Level 3 is very airtight. So just make sure you're looking at the technical documents and the information that's going on there, because they are very large windows and doors. And if they're kind of leaky, you have a very large leaky window and door. And then they blame the airtightness guy. I don't understand. But
very good point, Kevin. And they can slightly be adjusted. It's one thing I have to mention. It's very, very important to put them in completely level. They're very sensitive to the way they're installed. So you have to have a means of maybe shimming it or getting it dead on level, because first of all, the operation of them won't be working well if it's not level, and then also the air tightness get affected if you start putting it out of square. But you can adjust a little bit the amount the doors pull when they close, so that the lift and slide works with a big lever handle. So when you move it down, you basically lift it on its rollers and it rolls, And then when you release that, it moves down on its track, and that's when the gaskets engage. So there is 2 gaskets on those ones, the ones we have. It's a very common hardware system, I think, that a lot of European companies use.
Awesome, thanks. I just wanted, any other questions there, Shaun?
Yeah, I got Chris with one, which is more of a generic window question, but Marcel, you've installed, I think, probably every passive house window company that's come into Vancouver. Chris, do you want to ask it?
Yeah, I was wondering, I mean, it's a fairly general question, not specific to this, but it occurred to me when we were looking at the custom job for the piping, you know, if you've got some kind of repair in a passive house building that requires cutting through the wall, you know, like either something like a major problem with a plumbing kind of change or something like that, how do you go about getting a repair properly done? Because it seems like it's important to get everything sort of back in its right place.
When you have a repair for a water leak or a HVAC leak or something, you just want to make sure you're vetting your professionals that are coming out, and then just make sure that they're going to repair and replace exactly what's there with the right product. So if they see a high density, pipe installation, that they're going to repair it the same way. High performance projects need high performance contractors that work on them. Your insurance companies will pay for the work to be replaced as like. So just make sure you're vetting them. I've had experience on one project in Brooklyn where he thought it was a water leak from his window, from his door on his balcony. And, I came there trying to repair the water leak, and our redneck little water test with the garden hose on the outside of the balcony revealed that there was no water leak from the outside to the inside. It was a condensation issue from the inside to the outside. So where they had jack studs and everything at the base of the door, over the 4 years that the project was there, condensation was developing and slowly creating moisture in that location that was wetting the drywall. So it's not always high performance projects they have issues that are not very common for repairs, and you can call on an expert like myself to really troubleshoot it. But the issue was condensation from the inside, not a water leak from the outside to the inside. So just
imagining with air tightness and things like that, it could be difficult to do a repair in such a way that it, keeps the air tightness and everything like that, depending on, how much you're cutting through. And
I would personally think that passive houses tend to be a little simpler to maintain, in that you don't have as many penetrations that can go through. If you have a penetration that's made, just make sure you're using the same materials that would go through it. But, I wouldn't be too concerned with it. And that's pretty much all.
Thanks.
No worries. Thank you.
All right, go back to questions. Kevin in New York had the window question, not Chris, but Chris, thanks for asking that. That was a good one as well.
Yeah, no, my question was just on manufacturer, and I think it was also answered that I should search older videos from Mark saying, what would be the windows that they were using.
Yeah, I'll chime in this, and then Marcel will probably talk about it too. Marcel's installed a lot of passive house windows from different manufacturers. Ideally look at ones that are local. We're lucky in Vancouver that we've got 6 passive house certified windows within an hour. And then Marcel finds new ones. And so this is a new brand of windows that he looked at. And can you name
it's an old brand. It's an old family business, but it's the first time they came over.
Yeah. Because what other ones you've done? The last project was
OptiWin as well. We've done a few of those. So we've used Cascadia, Euroline. We haven't used Fenster yet.
And another one that's being used a lot here is Veta windows. So there's a lot of window choices now. We're pretty lucky. So again, I've got a few more in the queue, but just to go through the latest poll. So who was credited for establishing the Canadian tuxedo? And 41% of you, the right 41% is correct, Bing Crosby. And then of course that plays into question number 2 is who is Harold Orr? As much as I thought that he would be Bobby Orr's brother, he actually built the first passive house in Canada back in 1976. And which building kick-started the Passive House movement in Canada? And it is the Osher House. For those that were on the Global Passive House happy hour, I made a visit there in the dark, but I was there a few weeks ago. So there's a little bit of Passive House Canadian history. So going back to questions, the next one we had queued up was Harvey.
Shaun, if I could just jump in on the Bing Crosby. He was at a hotel in Vancouver and was told that he wasn't allowed in because he didn't have proper attire on. He was wearing a denim jacket, a denim shirt, and denim pants, and he was told he was not properly dressed. And then Levi's found out about it, and they coined the phrase the Canadian tuxedo, created by Bing Crosby.
I appreciated that you showed us your butt. That's a new one for the Canadian the tech event.
I think it was my thigh and sorry.
Pushing
though,
the
that
PG
wasn't
again.
that wasn't formal enough, though. He didn't have the denim shirt on with a denim vest. That was the problem. Marcel, good to see you. My connection to Marcel quickly is that he was my instructor on the trades course, and great guy, and always has an answer, and I always like to quiz him. So my question is, how did you tie in? I know you'll always love these questions from me. How did you tie in with your air barrier with the window and your insulation all the way around?
So the project is using WRB air barrier, so exterior. We use mineral wool insulation, 6 inches on the outside. So that means the WRB is sitting behind the mineral wool. And then we basically taped with Siga, sorry, Shaun, Siga tape over those wood windows. We used the Wiggle from, we used the wide one. We had to cover basically all the wood, the exposed wood, right? Because at some point, potentially, there could be some moisture back there. At the sill, we used a stronger membrane. You could see that in that picture. It was one of those foil-faced peel and stick membranes. And we typically around windows do the belt and suspenders approach, where we seal outside and inside. So we also use the fem trim on the inside.
Thank you. No caulking and no fillers at all as well? Like for drainage
actually,
or anything like that? Was there any concern?
We tried something new this time to fill the gap. We used that expandable foam gasket. There's a few different brand names. I forgot on the top of my head now, but it's basically like a piece of memory foam. It comes in a roll, and it starts over time to expand to, you can buy it in different widths, like back to its original size. So instead of using spray foam, we use those. They claim that it can be airtight as well in Europe, but it always comes down to the corners and, shims in the way, and I didn't trust it for that. But it's a good way to fill the gap without using spray foam.
Yeah, Tremco makes one, the Tremco Trio by Ilbrook. There's also Hanobond available.
And
I think you showed did you not show a picture of that in our course, actually, on one of the last days of the window? You're right, it's gray and it was thick, and it had some adhesive on both sides, right? If I recall correctly.
Typically on one side, so you can either install it in the rough opening first or attach it to the window. There's 2 common ways to do it.
And Harvey, because we have you, how'd you do on your tradesperson test, my friend? Unofficially.
Well, I can't really say unofficially. Maybe if Marcel or Louise wants to say, but I personally can't say that I passed. I mean, other people may be able to say I passed, but I don't really want to say, but I think it was okay.
We have to wait for the results, though, coming from PHI, Harvey.
Gotta wait for the mothership, Harvey.
Oh no, I better make a change to my webpage.
Yep. Hold on until you get the official letter.
Yeah.
Until you get added to the PHI's database, forget it. All right. So thanks, Harvey. So we're trying to keep up. Mary had the next question.
So you mentioned that the window was a little finicky with like being level, and I just wondered if you ever have the experience of having to adjust the window like a year later or anything, and if so, how would you go about doing that?
We actually had to adjust it even within the few months we've been building it. So we had one that was starting to bind, so we had to go back, and we had to cut some tape and level it out again, because we were a bit in a rush on one of them to get it in, and it was off by maybe 1/8 of an inch over 20 feet, and that was enough to make it bind. So we learned the hard way, like we typically do in construction. Yeah, so I think you're going to realize fairly quickly during construction if it's not there and you have time to fix it. But if you have to go back, I mean, there's not really much different approaches than getting underneath it and try to shim it straight. So do it right in the first place is what I'm saying. Spend your time to do it right.
Marcel, though, to speak to that, the fact that months later you went back to make an adjustment that was 1/8 of an inch over 20 feet, that's remarkable, and that's what really needs to be talked about, right? To know that you want it perfect and you're willing to dial that in, that's not a measure that everyone will do, and way to go. That needs to be pointed out.
Thanks, Mark.
Yeah, when it comes to details, Marcel is definitely there. Okay, thank you, Mary. Enrique, off to you. And then we've got a couple updates to share with the group. So stick around.
I just was wondering, that type of sliding doors that you have there, how do they compare with in the U value with regular, I mean, fixed windows or tilt and turn windows? I have a project here which the owner wanted sliding doors, and when I put them into the Wi-Fi, I mean, it went through the roof. The heating demand, it's a difference like 70 to 20% in energy consumption just because of the sliding doors. So I wonder what's your experience there with those type that you were using there.
So you got to look at the U value of the whole window, and the way we look at it in passive houses, even the insulation, right? And the U value of the window has a lot to do with the size of the opening, because the frame is the poor performing part, and the glass is always better performing. So the glass we used in the tilt and turn and in the sliders was around 0.5 U value, so very decent, triple glazed. The frame for the tilt and turn is around 0.8, 0.85, something like that. And for the sliders, it's actually quite a bit higher. It's somewhere between 0.9 to almost 1.2, depending on, the weakest spot is where the two mullions cross, because it's basically just wood there. But because it's wood, it's better than any other material, like, that's higher conductive, like steel, etc. So to tell you exactly what the U value of that 20-foot by 9-foot window was, it was actually 0.6, which, because it's so large, proportionally, it's mostly glazing at 0.5, and there's only a few spots where the frame is, penalizing the overall U value.
That's in watts, or?
Yeah, that's in metric. Sorry, I don't do imperial.
Because I mean, especially the junction. I mean, the thermal bridge of the junction is in this type of windows I was using. The slide doors I was using was crazy. It was like 1. Well, that's
see, that was the same in ours, but because of proportionally with the whole window was so big, right, with the sliders, the U value of the window assembly is still 0.6.
Well, maybe that's the reason why yours worked better, because of the size. Yes.
You still could have a problem with low temperature and having condensation being hit with that. So that's beside it.
Right. Okay.
At the frame. Yeah. But definitely, wood is a great material for windows. I mean, the reason why they are so deep is because they need to hold that structural load, right? And 9 inches deep. And
this I'm working with are from Clearwall in
I've dealt with those too, different European like metal windows as well. They're not that suitable, I think, for high performance.
Okay.
Just to add on top of that as well, the PHPP or Woofy passive, whatever you're using, it's about a balancing act, and you can make up for it in roof insulation or in other areas. But the one thing to keep in mind to balance your energy model is like John Mitchell mentioned in the chat about the surface temperature. You could develop condensation, and sometimes you have to throw heat at those really large lift and slide windows to prevent condensation at those areas. And the other thing to point out, which we talk about in the tradesperson class that each of us teach, is that large glass is good, small frames is very good. You get most of your heat loss at the frames. And if you could minimize that and say you want to go 19 by 20 and its center of glass is very good R value, it's all good. So thanks, guys.
Thank you.
Thank you, guys. And Marcel, this time in the show where we always ask someone to say thanks to the mentor or someone you learned something from. So who do you want to say thanks to tonight?
Guido Wimmers. So besides Kevin and Sandra and all these Monty and all these great people that I've met here in Vancouver. I came from Switzerland. You would think I learned about passive house in Switzerland. No, but it was by this guy, Dr. Guido Wimmers, who has his doctorate in building science from the University in Innsbruck. And I got to meet him in 2007, and we actually were working on a project together, which was like a passive house prototype. We didn't go to full certification, but it's the first time we, brought airtightness down below 1 and started working with some exterior insulation and some OptiWin windows at the time, high performance windows, put in a local HRV. And it wasn't that great, but at least it was an HRV. And we've become friends. And Guido is a great mentor. He's been up in Prince George since 2014 now, I think, as the chair of UNBC, Wood Innovations campus. He's teaching passive house through the course there, through the 1-year wood engineering course. And some great graduates come out of there. I think we have maybe some on the call even. So anyone who's interested, look it up. It'd be worth to spend a year in Prince George to learn more from this amazing guy. And yeah, thanks a lot, Guido. You're a great inspiration and a great mentor.
So I just wanted to shout out that myself, Jesse Matthews, and Marcel will be presenting at the Passive House Canada Summit tomorrow. We will be presenting about the field notes from projects in how you take your airtightness team and get them up to speed. Not quite the exact intro. I don't have it in front of me, but I wanted to just share my screen really quickly and pull Jesse in.
Hey, Kevin, was that a detail where we're supposed to put our beer cans and banana peels during the construction site?
You know it.
Kevin, Mark, while Kevin's finding the stuff, you want to say goodbye to the listeners, and then you can kick things off, and then Zach can say a couple things, and we'll kick off the overtime. Because you didn't have a chance to say hello to everybody.
So I guess when I'm saying hello to everybody. Nice to see all the nice tuxedos out there tonight. Very well done. Marcel, thank you for everything. And more importantly, the people that are on here tonight for episode 4, you're the reason that all of us do this. So thank you. Much respect for being here. If you're not here next week, we will find you. So be aware. I see you laughing, but I'm serious, so that's not funny. I will find you. Yeah, we're gonna kick off. I forget what we call it. What after party? What do we call it? Overtime. Okay, we're gonna kick off the after party. So
all right. So when I was talking about funk, and you guys remember my EPDM gaskets and where it came from, Jesse Matthews sends this to me, and he did the same exact I did. So he took EPDM gaskets. We never even talked about it. We haven't had a conversation about it, but he ordered EPDM. I think he may have stolen it from the roofer on site, and he made his own grommets and gaskets. And you can quickly see what's happening here. He's got the rubber, he cut it out. He's connecting it to the vapor barrier down below. Perfect, neat, awesome, tied in using the tape that works on the plastic. And it's all neat, looks perfect, is perfect. So in silos, we did it on our own. And to me, this is the funk. All right. And Jesse is on the call. Jess, you got anything to add on this?
Yeah. What's funny about this is we literally pulled out our phones when we saw each other in New York. And I was like, I know how to seal pipe groupings. And you're like, pulled out the exact same thing. And we're like, so it's cool to see like everybody's struggling, but the solutions exist. You just have to discover them, or somebody else will tell you about them. But I love the EPDM gaskets. Where I love them is a pipe grouping like that, and those are 4-inch pipes. and there was a lot of them, and they were up against the foundation wall, and like that's like still scares me to think about having to tape that. And on a larger project where you have a number of crews working, the beauty of a solution like that is you don't have to find a master taper. You can find somebody that can cut a piece of EPDM. You can find a person that can cut the holes in the EPDM. And you can find somebody that'll slip it over those pipes until the air boss or the pro taper can come in and slide it down and tape it. You don't need like your most talented crew member to spend an hour of their day taping a pipe grouping. So it divides the labor up where each person has a simple job, but in the end you're achieving a great result. I also love it because EPDM, you can have like a 1/2 inch upturn onto your pipe rather than put like a 4-inch spool of tape. A lot of times you'll see guys taping and they're just like taping around and around, and then the plumber has to come on and put like a drain or a coupling on that, and he's never going to get the tape off. So EPDM is a great solution. If you get the right EPDM, it is often dirty and not very sticky. So yeah, that's all I have to say about EPDM. Not really. I mean, I got some on my desk right here. So there's like there you go.
I could show you some pictures on if you just hand somebody a grommet or a gasket and don't really train them, how they can put it on backward. And
I think we all got a collection of those.
Yeah, it can still be wrong, but it minimizes, it gets you there, I guess. And it gets a bunch of people in the game rather than just causing one person to be stuck in one area of the building for the whole day,
Teamwork makes the dream work. So speaking of which, let's kick it off to Zach.
All right, great. Thank you. So I just want to say that none of this would be possible without support of our founders. So I want to thank our founding sponsors, 475 High Performance Building Supply, Backstingui Architects, Mitsubishi Electric Train, HVAC US, RDH Building Science, StoCorp, and Zola Windows. Also, thank you to NYSERDA, our stakeholder partner, and thank you to our patron sponsors, Inotech Windows and Doors, Morrison Hirschfield, and Partel. And I'm going to make a couple of announcements about events that are coming up. One I don't have a slide for, but I'm going to be there. It's going to be a great event tomorrow. It's a Q&A session with PHI about component certification with Edward Lowe's. So we've been talking a lot about components in these Construction Tech Tuesdays, and this is going to give lots of information about the process and should be a great event. So don't miss that. Now, tomorrow also, so that's going to be at 8 p.m. Amsterdam, Berlin, Bern, Rome, Stockholm, Vienna time. So I will get you the correct information in terms of hour and link to this Q&A in the chat in just a moment. So later tomorrow, we will have our Global Passive House Happy Hour, and it's going to be aligned with, again, the Passive House Canada Summit, and it's going to be featuring a really inspiring talk. Shaun and I and a couple others just saw it in run through earlier today about what's going on in the city of Vancouver by Chris Higgins, and he'll also share 3 key takeaways from the summit. So that's going to be great. Please join us. I'll share information in chat. Next Monday, December 14th, we're having our second Passive House Prefab Summit. This one is going to be sponsored by VaproShield and RDH Building Science. We have a brand new slate of guests and a new format, so it's going to be lots of really fresh and exciting content. Please sign up for that. I'll share the registration link. And then next Tuesday, we have an exciting construction tech program for you. Shaun, do you want to say a couple of words about this?
Sure, because we've got the Prefab Summit on Monday, we might as well carry over prefab details on our construction tech. And so haven't finalized the person, but he's almost ready. So we've got a prefab all-star coming next Tuesday to talk about the technique, the technology, and it's gonna be fun.
Cool. And then finally, I want to show just a little thing to kind of plug Passive House Accelerator.
Construction tech.
Technical.
Technique.
Technology
Tuesdays.
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 on Tuesday.
Every Tuesday.